Okie dokie. In this problem, we are given a table of x values and function values for three different functions, f, g, and h, and the question is whether or not these functions have constant rates of change. In other words, do they have a constant slope the entire time? So, how we'll check this is starting with the function f, we will find the slope between two pairs of x values. So we could start by finding the slope between, say, 0 and 4, and then we could find the slope between 6 and 9. It doesn't matter which pairs you use as long as you use two different pairs. And so we're going to find the slope between two pairs of values for f. We're going to verify that those two slopes are equal to one another. If they are equal, that means we will have a constant rate of change for that function. And then we'll just repeat the process for functions g and h. So let's not waste any time for function f. We are finding the slope between 0 and 4 first. So keep in mind we're doing slope formula, so y2 minus y1 over x2 minus x1. So if we do that between 0 and 4, we know that the x values will be 4 minus 0 on the bottom. So then the corresponding y values to 4 and to 0 are -1 and -5 respectively. So make sure, since we're subtracting a negative, to use parentheses around that -5. All right, so I'll go ahead and write that out, and we may be able to at least write this mostly by hand. Let's see, so -1 minus the -5 would be -1 plus 5, which should give us 4, divided by 4 minus 0, which is 4, which is equal to 1. So then let's find the slope between 6 and 9 for the function f. So we have y2 minus y1, or 15.2 minus 4, all divided by x2 minus x1, so 9 minus 6, and this looks a little strange. But let's see what we can do by hand. So 15.2 minus 4 would be 11.2, and then 9 minus 6 would be 3. So I'm not seeing this fraction being equal to 1, so f likely does not have a constant rate of change. So we will repeat this process for g and for h, and I'll just use the same x values each time. So we are finding the slope between 0 and 4, so we start with -19.1 minus 1.5. Is it 1.55? Yeah, 1.55. And then all divided by 4 minus 0. This looks a little more complicated. I'll probably save this for Desmos. Let's go ahead and set up the next slope between 6 and 9 for the function g. So we'll do -44.9 y2 minus -29.4 for y1, and then that's all divided by 9 minus 6. Again, pretty complicated with the decimals, so I'll just save it for Desmos. Let's go ahead and set up function h. Let's use a different color, stay consistent. We'll do h, and we'll do between the same x values again. So we'll use these y values, so I'll start with -2.5 minus 1.5 for y2 minus y1. Again, we have 4 minus 0, so it's just a lot of setting up. I'll go ahead and set up the slope between 6 and 9. -18.7 minus make sure to use parentheses, 7.5. And then we have 9 minus 6 on the bottom again. Right, everything looks good. I'll go ahead and type these into Desmos. So with the results from Desmos, let's go ahead and kind of just drag and place them in here and write down the results. So for function g, for the two slopes, we got -5.1625, and for the second slope, we got -5.16 repeating, -5.16 repeating. So these two slopes, I would say, are close enough. So as long as you get something that, they're relatively close enough to say it's a constant slope, an equal slope, then that should be enough to say it's a constant rate of change for that function. So g checks out. We said that f was not a constant rate of change since these two slopes were not equal. And then for h, it looks like the slopes we have are -1 and -3.7. So -1, -3.7, definitely a little far off from one another. So H does not have a constant rate of change. So it looks like in this case, G is the only one that has a constant rate of change. So looking through our options, all three do not have a constant. F and H do not have a constant, while G has a constant. I think that's what we said. So let's break out the eraser, and we see that B is in fact our answer. I'll work out another example for this one. Feel free to check it out.